Welcome to the deep dive. Today, we're tackling a really interesting question. How do different levels of gender equality around the world actually connect with the number of women and men in STEM fields?
Yeah, it's a fascinating area.
And we've got a great guide for this, a review article titled Cross-Cultural Patterns of Gender Differences in STEM, Gender Stratification, Gender Equality, and Gender Equality Paradoxes. It just came out in Educational Psychology Review this past March.
Right, hot off the press.
Yeah.
And what we're really digging into is this relationship between how gender equal a country is and, what that means for STEM.
STEM meaning science, technology, engineering, math.
Exactly. Things like how well students do,
Yeah.
what they believe about their own abilities, their interest levels, and ultimately who actually goes into those STEM careers.
And this isn't just a small glance, is it? The study uses data from the big PISA surveys.
Yeah, PLACES, that's the Program for International Student Assessment. They use data from 2015 and 2018.
And the numbers are pretty staggering, almost 1 million students.
Just about, yeah. 941,475 students across 78 different countries and regions. So a really wide scope.
Okay, so with all that data, the researchers were mainly testing, what, two main ideas, sort of competing theories?
That's right. The first one is, well, it's kind of what you might expect. It's about gender differences in society overall.
You mean like basic inequality?
Pretty much. The idea is that in countries where there's just generally more inequality between men and women, maybe fewer opportunities for women in education or jobs, that kind of thing,
Hmm.
you'd probably see bigger gaps in STEM as well. Fewer girls might be encouraged or even just have the chance to really excel in science or math.
That makes intuitive sense. Researchers call that the gender stratification hypothesis, right?
Exactly. Gender stratification. If the playing field isn't leveled generally, it likely won't be level in STEM either.
Okay, makes sense. But then there's the second idea they looked at, which is, well, it's a bit more confusing. The gender equality paradox.
Right, yes. This is where it gets really interesting and kind of counterintuitive, like you said.
Right.
The paradox suggests that in countries that are actually more gender equal overall, places we'd think of as progressive,
Yeah.
you might, surprisingly, find larger gender gaps, with males being more dominant in STEM fields.
Wait, so more equality leads to bigger gaps favoring men in STEM? That seems backwards.
It does. It's the opposite of the first hypothesis, and yeah, it's caused a lot of discussion. Why on earth would that happen?
Exactly. That's the million-dollar question, isn't it? So our mission today is to unpack what this big study found. Does the data support simple stratification or this weird paradox or something else entirely?
Well, buckle up, because the main takeaway right off the bat is that actually the study found pretty inconsistent and generally weak support for both ideas.
Oh, really?
Yeah, it wasn't clear-cut. The evidence just didn't consistently show that more inequality always means bigger STEM gaps, or that more equality always leads to this paradox. The reality seems, well, messier.
Messy is a good word. So if these two big ideas don't really hold water consistently, what's making it so complicated? Surely there's some link.
Oh, definitely. The researchers pointed to a few things that might be clouding the picture. One factor was specific outlier countries,
Outliers,
meaning a few countries whose results just didn't fit the general pattern seen elsewhere. Maybe they had unusually high female participation in STEM despite lower overall equality, or vice versa. These unique cases can kind of skew the average.
Right. A few exceptions can make it hard to see the rule. That makes sense. What else?
Well, the fact that they used data from two different years, 2015 and 2018, also seemed to play a role. The patterns weren't always identical across those two snapshots in time.
So things might be changing. Or maybe the effects aren't stable.
Could be. Maybe societal shifts are happening, or maybe some findings are just specific to one assessment period.
Oh.
Also, remember, this was a review article, too.
So they looked beyond just this one PISA analysis.
Exactly. They incorporated findings from lots of other studies in the field, and those studies often use different data sets, not just PISA.
And those different data sets might show different things.
Sometimes, yeah. That adds another layer of inconsistency when you try to synthesize everything. It's like comparing apples and oranges sometimes.
Okay, so different data sources, different years. What else muddies the waters?
How you actually measure gender equality matters a lot, too.
Yeah.
Not all studies define or measure it the same way.
How so?
Well, some use really broad composite indexes trying to capture everything at once. Others might focus specifically on, say, economic equality, or political representation, or educational attainment for women.
And depending on which aspect of equality you focus on, you might see a different relationship with STEM outcomes.
Precisely. A country could look good on one measure, like women's health, but maybe less so on economic participation, and that difference could definitely influence the findings related to STEM.
Okay, that adds complexity.
And one last thing they mentioned, different studies often use different statistical models, the specific mathematical techniques used to analyze the data.
And the math itself can influence the results you get out.
It can, yeah. Different assumptions built into the models can sometimes lead to slightly different conclusions, even with the same raw data.
Wow. Okay, so we've got outlier countries, different time points, diverse data sources, varied ways of measuring equality, and different statistical approaches. No wonder it's hard to find a simple answer.
Exactly. It really highlights that this isn't a simple cause and effect thing. It's a web of interconnected factors.
Now, something else the study dug into was this idea of relative strength measures. That sounds important. Can you unpack that for us?
Sure. So instead of just looking at a student's score in science or math or reading in isolation,
Mm-hmm.
they looked at how well a student did in one subject compared to how they did in the others. Like, maybe you're good at everything, but are you relatively better at science compared to your own math or reading scores?
Ah, okay. So it's not just about being good at math, but being better at math than you are at reading, for instance, within the same person.
Exactly that. It's about identifying where an individual student's academic sweet spot might be relative to their other abilities. The thinking is this relative strength might influence their interests and choices.
Okay, and how did they measure that? Sounds tricky.
They used a pretty sophisticated statistical model. Basically, it allowed them to compare each student's performance across science, math, and reading in a robust way, accounting for their overall ability level.
And this helped them see which relative strengths were linked to things like wanting a STEM career?
Yes, precisely. They looked at how these relative strengths predicted STEM aspirations.
So what was the big finding there? Was it being relatively strong in science that mattered most?
Actually, no. And this was quite surprising. They found that general academic achievement, just being a good student overall, was important, yes. But also, having a relative strength in math compared to reading was a stronger predictor of STEM aspirations than being relatively strong in science compared to the other subjects.
Wow, hold on. So being comparatively better at math than reading was more important for wanting a STEM career than being comparatively better at science.
According to this analysis, yes. That's what the data suggested.
That really goes against common assumptions, doesn't it? You'd think science strength would be key for STEM interest.
You absolutely would. But it seems that maybe having that comparative advantage in mathematical quantitative reasoning, more so than in verbal skills, might be a more powerful driver for students considering STEM fields.
Perhaps because so many STEM fields rely heavily on that kind of mathematical thinking?
That could be it. It suggests that maybe feeling confident in your math abilities relative to your language abilities is a really crucial factor in seeing yourself in a STEM future.
Less about loving biology lab, more about feeling you have an edge in the underlying quantitative skills.
That seems to be a key takeaway here, yes. That relative math strength appears quite significant.
Okay. Now, the study also looked at actual STEM aspirations and even graduation rates across countries, right? Connecting it back to that country level gender equality.
Yes, they examine those outcomes too.
Mm.
And, well, consistent with the earlier findings, the link back to country-level gender equality was, again, not very clear or straightforward.
So no simple pattern, like more equal countries have more equal STEM graduation rates.
Not consistently, no. They didn't find a reliable pattern where higher national gender equality automatically translated into more balanced gender ratios in terms of who wants to go into STEM or who actually graduates in STEM fields.
So that paradox idea keeps kind of popping up, or at least the lack of a simple positive correlation does. Higher societal equality doesn't automatically fix STEM representation.
That seems to be the consistent message. It reinforces that achieving broader gender equality, while incredibly important for many reasons, might not be the magic bullet for achieving gender balance specifically within STEM. Other factors seem to be strongly at play.
It sounds like the strength of this research is looking at both levels, the individual student with their relative strengths and the national context of gender equality.
Absolutely. By combining those perspectives, the micro and the macro, if you will, they could get a more nuanced picture of the decision-making process.
It's not just societal forces pushing people, and it's not just individual talent in a vacuum.
Exactly. It's the interplay. How does a student perceive their own strengths, like that math versus reading comparison within the opportunities and expectations of the society they live in? Both matter.
A student might be great at math, but if the culture tells them it's not for them, that's a barrier.
Precisely. Or, conversely, even in a very equal society, if a student feels their strengths and interests lie elsewhere, based on those relative academic abilities, they might choose a non-STEM path. Individual choice and aptitude still play a huge role.
Now, you mentioned they did some extra analysis too, looking for non-linear relationships. What was that about?
Yeah, they specifically looked at the Gender Gap Index, or GGGI. That's one common way to measure overall gender equality. They wanted to see if the relationship between a country's GGEI score and the gender differences in STEM aspirations wasn't just a straight line.
Meaning, maybe the effect changes dramatically once a country reaches a certain level of equality, like a curve or something.
Exactly. Does the pattern shift at very high or very low levels of equality? But interestingly, they didn't find any statistically significant evidence for that kind of non-linear pattern,
Hmm. So, no tipping point where things suddenly change.
at least not based on this analysis with the GGGI and STEM aspirations. The relationship, or lack thereof, seemed fairly consistent across the spectrum of equality levels measured by the GGGI.
Okay. And it's worth highlighting again that all this analysis was based on publicly available data, right?
Yes, absolutely. They made it clear it's secondary data analysis, mainly using the PISA results, which anyone can access via the OECD website.
That's really great for transparency and for, other researchers or even curious listeners.
Definitely. It means people can check the findings, run their own analyses, explore different questions using the same data. It really helps move the field forward collaboratively.
Okay, so let's try and wrap this up. The big headline seems to be that the link between a country's overall gender equality and the gender gaps we see in STEM is, well, complicated.
Extremely complicated, yeah. Those initial simple hypotheses, stratification, or paradox, they just don't capture the full picture consistently across the globe.
It's not a straightforward relationship.
Not at all. The reality is much more nuanced.
And drilling down to the individual level, it looks like how students perceive their relative academic strengths, especially being stronger in math compared to reading, might be a really significant factor driving STEM aspirations. Maybe even more so than just being good at science relative to other subjects.
That's a really crucial insight from this work, I think. That comparative advantage, particularly in math, seems potentially very important for sparking that initial interest and confidence to pursue STEM.
So, this really leaves us with a big question then. If just pushing for overall gender equality at the national level isn't the guaranteed fix for balancing gender representation in STEM, what else should we be thinking about?
Exactly. It pushes us to think beyond that single dimension.
Which brings us to our final provocative thought for you listening. Given these complex findings, what might be some more effective, maybe more targeted approaches beyond just general equality initiatives that could actually encourage more balanced gender representation in STEM fields?
Yeah, for instance, should there be a much stronger focus, starting really early, on building confidence and competence in mathematics for all students, regardless of their gender? Could that be a more direct lever?
Or maybe we need to look harder at cultural perceptions. How are math and science talked about? Are certain skills implicitly valued differently for boys and girls, even in supposedly equal societies?
There's definitely still a lot to unpack there. It's about individual skills, choices, and the subtle societal messages students receive.
Definitely food for thought. And if this has piqued your interest, we really do encourage you to check out the PISA data for yourself or dive into the research cited in this review. It's a fascinating and really important area.
Absolutely. Thanks for exploring it with us today.